a negative 3 and 5. And of course, we know that this is a rectangular form. I would like to put it in the polar form, and the polar form is written as r theta. So this is the polar form. We know already that the complex form of this is negative 3 plus 5i. So this is the complex form. So how do we express this in the polar form? So we need r, which is actually the magnitude of our vector, and the angle from the positive x-axis. So if we're going to graph this, that will be negative 3 and 5. So that is our point. So if this is our Cartesian plane. Okay, we want the angle coming from here. So we draw the magnitude, it's like that, and the angle that we are looking for should be here. Okay, so the first thing we do is to find the r, which is given by the square root of x squared plus y squared. And in this situation, it's negative 3 squared plus 5 squared. So therefore, if we put this in our calculator, so that would be negative 3 squared plus 5 squared. And so our magnitude, which is also equivalent to the value of r, is equivalent to 5.83. So the length of this line is 5.83, whose coordinates of that endpoint is negative 3 and 5, and the measure of our line is 5.83. All right. Now we will find the angle, and how do we do that? We have done that in treating our complex numbers as vectors by finding the inverse function of tangent y over x. And we know that y is 5 and our x is negative 3. So therefore, this is equivalent to tangent 5 over negative 3. And if we are going to make use of the calculator, so shift tan 5 divided by negative 3. It gives us an angle that's equivalent to negative 59.04. So our angle here is negative 59.04 degrees. So however, this angle doesn't mean that it's going to be this. And looking at this, the angle here is more than 90 degrees. An angle in standard position means that our angle is either coming from the positive x-axis or the negative x-axis. So in this situation, our angle is coming from the negative x-axis. Obviously, it cannot be this. So therefore, it is referring to this angle, negative 59.04. It's negative because it's going in a clockwise direction. This is a positive angle. It's going in a counterclockwise direction. So therefore, to find this angle, if you're going to look at our figure, okay, that constitutes half circle, which is equivalent to 180 degrees. It's a straight angle, and we know that a straight angle measures 180 degrees. So to find this, we will subtract these two. So the angle that we are looking for is equivalent to 180 minus 59.04 degrees. So let's solve it. So 180 minus 59.04. And that gives us 120.96 degrees. So the angle is 120.96 degrees. So we have solved the problem. The R angle form or the polar form of our rectangular form negative 3, 5 is also the same as this polar form, that is 5.83 and an angle of 120.96 degrees. You can also write it like what we had. It's equivalent to 59.04. This can also be written as 5.83 and negative 59.04. But as much as possible, we would like to make the angle positive. That is why we need to like manipulate it and find ways to make it positive coming from the positive x-axis as a basis. So this only shows that this one is going from the negative x-axis and this one is going to the positive x-axis. As a standard, we would like our angle, our direction coming from the east line, the positive east line, not from the west line. And that's it.